Beneath the shifting sands of the Iranian desert lies a fortress of concrete and steel that the Nazis were never supposed to crack. In 1941, engineers raced against time to build a bunker so advanced it could repel an elite paratrooper assault. We are going inside the subterranean blast walls that protected the world's most vital fuel reserves. Welcome to the survival bunker. Here, we study the brutal reality of surviving war zones, sieges, and battlefield collapse. Today, we're not examining a military installation or a naval vessel. Instead, we're examining an oil refinery, specifically the Abadan Refinery on the southwestern tip of Iran, which in 1941 was the single largest oil refinery on Earth and the most strategically critical industrial installation in the Allied war effort. The engineering decisions made to protect it from German sabotage and potential airborne assault in the summer of 1941 represent one of the most consequential defensive fortification programs of the Second World War, and honestly, one of the least examined. This is the story of how engineers turned a vulnerable industrial complex into a desert fortress, and how that fortress secured the fuel supply that kept Allied armies moving. To understand why Abadan required fortification in 1941, you have to understand what it represented in the context of the global war. The Abadan Refinery, operated by the Anglo-Iranian Oil Company, the company that would later become British Petroleum, had been in continuous expansion since its founding in 1912. By 1941, it was processing approximately 8 million tons of crude oil annually, making it the largest single refinery operation in the world by output. It refined the crude extracted from the Iranian fields of Khuzestan into aviation fuel, diesel, and lubricants that supplied British forces across every theatre of the war: North Africa, the Mediterranean, East Africa, and the expanding Pacific operations. The Royal Air Force's operational capacity was directly dependent on Abadan's output. The British Eighth Army's tanks and trucks ran on fuel that had been processed there. The geopolitical situation surrounding Iran in the summer of 1941 made the refinery's vulnerability acute. Reza Shah Pahlavi, Iran's ruler since 1925, had pursued a deliberate policy of balancing British and Soviet influence with German commercial and technical relationships throughout the 1930s. By 1941, approximately 2,000 German nationals were present in Iran, engineers, technicians, and commercial representatives whose presence the British and Soviet intelligence services assessed as including a significant proportion of intelligence and sabotage operatives under commercial cover. On June 22, 1941, Germany launched Operation Barbarossa, the invasion of the Soviet Union along a front stretching from the Baltic to the Black Sea. The German advance into the Caucasus region, which progressed with alarming speed through the summer of 1941, brought Wehrmacht forces toward the Soviet oil fields at Baku and toward the northern approaches to Iran. A German breakthrough to the Caucasus, followed by a southward drive through Iran, was not a theoretical scenario, it was an operational possibility that Allied planners were actively assessing. The specific threat to Abadan was, sabotage and airborne assault. German Fallschirmjäger, those elite parachute infantry who had really demonstrated their operational capability in the conquest of Crete in May 1941, represented a force capable of seizing or destroying a critical installation through vertical envelopment before conventional ground forces could even respond. A Fallschirmjäger operation against Abadan, combined with sabotage by German agents already present in Iran, could destroy the refinery's processing capacity much faster than any ground assault. The Anglo-Iranian Oil Company's engineers and the British military command in the region, they knew this. They had been preparing for it. The fortification program at Abadan drew on engineering principles developed for industrial facility protection that the British had been refining since the very beginning of the war, The core challenge was honestly unique. A refinery is not a military installation. It's this interconnected system of processing vessels, pipelines, storage tanks, and distillation columns spread across a large surface area, and most of it simply can't be concealed or hardened without compromising its operational function. You can't put a refinery underground. You can, however, protect its most critical and vulnerable components with hardened infrastructure and design the facility's layout to contain and isolate damage. Reinforced concrete protective structures were constructed around the refinery's most critical processing components, the distillation columns and associated heat exchangers that really represented the irreplaceable core of the facility's processing capability. These structures were designed to absorb blast overpressure from aerial bombardment and contain fragmentation from near-miss detonations. The concrete specification used in these protective structures was considerably heavier than standard industrial construction. We're talking walls of sufficient thickness to defeat fragmentation and reduce the overpressure transmitted to the protected equipment behind them to non-damaging levels. The blast wall system was the architectural response to a specific threat, the chain reaction explosion. Now, a refinery contains enormous quantities of flammable hydrocarbons in its processing vessels, pipelines, and storage infrastructure. A single ignition point, whether that's a bomb hit, a sabotage device, or even an incendiary round that ignites stored hydrocarbons, can, cascade through a connected facility as burning material propagates from one vessel to the next through pipeline connections and radiant heat transfer. The blast wall system divided the refinery's processing areas into isolated zones with reinforced concrete barriers between sections designed to prevent fire and overpressure from one zone propagating into adjacent zones. So a successful attack on one section of the refinery would damage that section, but crucially, it would not destroy the entire facility. This compartmentalization logic was directly analogous to the watertight compartmentalization applied to warships, the very same principle that, kept the USS Samuel B. Roberts afloat after her mine strike. The idea was simple: contain the damage to the point of impact, prevent propagation, and preserve the functional integrity of the undamaged sections. The storage tank farm, which held the refined output awaiting shipment, was earthen bermed with compacted soil barriers between individual tanks. This earthwork, while not reinforced concrete, served the same blast isolation function for storage as the concrete walls did for processing. A detonation in one tank would be contained by the surrounding berm rather than propagating through the stored fuel reserve. The defensive fortification of Abadan was not limited to passive structural hardening. The facility incorporated active defensive positions integrated into its industrial layout, a design philosophy that actually used the refinery's own physical geography as a defensive force multiplier. Defensive pillboxes and firing positions were constructed at key points around the refinery perimeter and at internal choke points, those access routes between processing areas that any assault force would need to traverse to reach critical targets. These positions were sited to create interlocking fields of fire. Each position covered the approaches to adjacent positions so that an attacking force that suppressed one firing point would immediately come under fire from flanking positions it had not yet engaged. An airborne assault force landing inside or near the refinery perimeter would face a defensive geometry that offered no dead ground, no approach route that was not covered by at least two firing positions. The industrial infrastructure itself contributed to this defensive geometry. The refinery's processing equipment, the towers, vessels, and pipe racks that covered the facility provided cover for defenders who knew the layout and denied clear fields of fire to an attacking force unfamiliar with it. A Fallschirmjäger force landing in the refinery complex would be fighting in a maze of industrial equipment against defenders who had prepared positions in that specific terrain. The industrial landscape that made the refinery appear vulnerable from the air was a defensive asset on the ground. Ventilation and gas management systems were modified to address the specific threat of incendiary and chemical assault. The refinery's enclosed processing spaces, control rooms, pump houses and valve stations incorporated positive pressure ventilation systems that maintained internal air pressure above ambient, preventing the infiltration of smoke, gas, or incendiary aerosols through unsealed penetrations. These systems allowed essential control personnel to remain at their stations and maintain refinery operation during an assault on the perimeter, a critical requirement since a refinery that loses controlled operation of its processing systems during an attack faces internal hazards from uncontrolled pressure buildup and hydrocarbon release that are as dangerous as the assault itself. The defensive fortification program at Abadan was tested not by a German Fallschirmjäger assault, but by an Anglo-Soviet military operation that the refinery's British operators had helped plan. On August 25, 1941, British and Soviet forces simultaneously invaded Iran in Operation Countenance, a coordinated military action designed to remove Reza Shah's government, expel the German nationals whose presence threatened Allied regional security, and secure Iran's territory as a supply corridor to the Soviet Union. The operation was executed with the Abadan Refinery's security as a primary objective. British forces from Iraq crossed the Shatt al-Arab waterway and moved on Abadan. The operation's initial phase included the seizure of Iranian naval vessels in the harbour adjacent to the refinery and the rapid occupation of the refinery complex itself before Iranian military forces or German agents could execute sabotage operations against it. The fortification of the refinery influenced the operation's execution in a specific way. British planners knew the facility had been hardened and its defensive positions manned. The speed of the British advance, designed to reach the refinery before Iranian or German forces could act, was calibrated against the assessment that the refinery could hold against a short-duration assault long enough for relief forces to arrive. The defensive fortification was not just a passive protective measure, it was a component of the operational plan. Iranian military resistance to Operation Countenance was limited and collapsed within days. Reza Shah abdicated on September 16, 1941, and was replaced by his son, Mohammad Reza Shah Pahlavi. The German nationals in Iran were expelled. The refinery remained intact and operational. The Abadan Refinery continued processing oil throughout the remainder of the war, supplying fuel through the Persian Corridor, the supply route through Iran to the Soviet Union that delivered approximately 4 million tons of supplies to Soviet forces between 1942 and 1945. The defensive fortification that had been built to repel a German paratrooper assault instead secured the facility against the chaos of a regional occupation and the ongoing threat of sabotage for the duration of the conflict. The defensive engineering principles applied at Abadan in 1941 did not remain specific to that facility or, that conflict. They established an architectural template for critical infrastructure protection that has been continuously developed and applied in the 8 decades since. The blast wall compartmentalization system, dividing a large industrial facility into isolated zones to prevent cascade failure, is, honestly, the direct ancestor of modern process safety architecture in petrochemical facilities. Current international standards for refinery and petrochemical plant design, including those published by the American Petroleum Institute and the International Association of Oil and Gas Producers, mandate separation distances and blast wall specifications between processing units that trace their engineering logic to exactly the compartmentalization principle applied at Abadan. Modern energy infrastructure hardening in geopolitically sensitive regions reflects the same threat assessment that drove the 1941 fortification program. Saudi Aramco's facilities, following the 2019 Abqaiq drone and missile attacks, which for a while temporarily disrupted approximately 5% of global oil supply, underwent a systematic hardening program that included passive blast protection for critical processing equipment and redundant processing capacity in geographically separated locations. The engineering response to the 2019 attack is philosophically identical to the response to the 1941 threat. Identify the critical nodes, protect them against the specific attack vectors the threat environment presents, and design for cascade prevention. The industrial fortress concept, using a facility's own physical geography as a component of its defensive architecture rather than treating security as a separate layer applied on top of the industrial design, appears in current planning for critical infrastructure protection in contested regions from the Persian Gulf to the South China Sea. Facilities that must operate in environments where sabotage, drone attack, or military action is a credible threat are more and more designed with their own physical layout as a defensive asset rather than a liability. The Abadan Refinery in 1941 was the first large-scale application of this concept under genuine operational threat conditions. The engineers who built its blast walls and integrated its defensive positions into its industrial layout did not have a historical precedent to work from. They developed the template under time pressure in a desert against a threat that was advancing in real time toward their position. The template they built is still being used. The German Fallschirmjäger never jumped on Abadan, but the engineering built to stop them was real, and its consequences were real. The refinery stayed intact. The fuel kept flowing. The Allied war machine kept moving. The best defensive engineering is, honestly, the kind that never gets tested in the way it was designed for, because the threat looked at what was built and made a different calculation. If this briefing changed how you think about industrial fortress engineering and the infrastructure that decided the outcome of the Second World War, subscribe to the Survival Bunker and share this video. Every share puts this research in front of someone who takes military history seriously. Hit the notification bell and we will see you at the next briefing.